Talk through chapter 16. This is my second attempt because the other one didn't have audio. But we're going to go through 16.1, calculating probabilities, and 16.2, sample space diagrams. We're going to talk about the content of each chapter. We're going to do some examples. And I'm going to talk through the questions for 16.1 because they're a bit confusing until you get to know how to do them. So I'll talk through some of the questions. For sample space diagrams, again, the content and the examples. And then I'll set the classwork right at the end. So you can skip forward to whichever part of the video is best for you, or you can watch it all if you want explaining. But we're going to go straight into calculating probabilities. So we've done calculating probabilities before in the past, but this chapter focuses on mutually exclusive events. So it's in it's in page 152 at the top, mutually exclusive outcomes it talks about. It says if one outcome happens, the others cannot. So for example, in a football match, the team can either win, draw, or lose. If the team loses, then it can't win and it can't draw at the same time. So it stops the other ones from happening. So if the team wins, they can't draw or lose. So when one thing happens, the others cannot. And where this comes from, mutually, you might have heard of a mutual breakup. That's when it's happening both at the same time, want it to happen. An exclusive, like an exclusive event, you might not let other people come to that event. So if it's mutually exclusive, when one happens, it stops all the others. And when the other one happens, it stops the others as well. So they're mutually exclusive. And what this means is the probability, I'm going to write prob a lot because I can't be bothered writing probability. The prob of mutually exclusive events, always adds to 1. So 1 or 100%, that's everything that could possibly happen. Okay, so the probability of these events always adds to 1. So if we have here, we take a football team, let's say the probability of winning is 0.3, drawing is 0.1, then what's the probability to lose? Well, the mutually exclusive events, it has to add to 1, so we know it has to be 0.6. You can do 1 take away 0.3, take away 0.1, 0.6. So because we know they have to add to 1, we can start finding probabilities using this. Okay, one of these things must happen, and none of the rest can. So they all add up to 1. So let's do an example. Here's a slightly different question. The probabilities of how a student gets to school. She either walks, takes the bike, the car, or the bus. What is the probability that she doesn't walk? So again, these are mutually exclusive because if she walks, she's not going to take the car, etc. We can check. So 0.2 add 0.1, add 0.4 add 0.3 equals 1. So that's good. So what's the probability she doesn't walk? Well, we've got two ways of doing it. We can either just add up the doesn't walks. So that's 0.3 add 0.4 add 0.1 is 0.8. So sometimes we can do it that way. But the better way, when they're asking for when something doesn't happen and it's mutually exclusive, we can just do 1 take away the probability that it does. And we get the same answer, you see? So let's try that for the second part. What's the probability she doesn't use the bike or the car? Well, we're going to do 1 take away the probability she does. So here's the bike, here's the car. So 1 take away 0.1 and 0.4. And we just get 0.5. We can check 0.2 and 0.3. Yep, it's 0.5. So that's mutually exclusivity. It's quite simple idea, but sometimes the questions are worded quite difficultly. So I'll talk through the questions quickly. Question 1. The first part says, what's the probability that the temperature will be below average? And the guy that's talking tells you the average is 60%, it's going to be average. The above average is 35%. So to be below must be whatever's left to make it. not above average, that's like it doesn't completely buy up down, not above average, so you can do 1 take away what will be average. And in part C, this is not below average.